power rule. 2 is a multiplier. Add 1 to that, and I'll have 5/2 times 2/5 minus 7 times u to the 3/2 times 2/3 plus c. And then I just have to back substitute for the u. What is u equal to in terms of x? Well, u is x plus 3. And I'll multiply my constants together at the same time. So I'll have a 4/5. U is x plus 3 to the 5/2 minus 14/3 did I do that wrong? Oh, sure. Missed my negative. Yeah, I just now looked at my work that I had worked out. Negative. That makes this not 3/2. This will make this 1/2. 1 plus a negative 1/2. Look at there. So then adding here, this will give me 3/2 times 2/3. 4/3. Oh, found my mistake. Back here, this will be 7u to the negative 1/2. Adding 1 to that, I will get 1/2. Multiplying by the reciprocal will be 2. So then that will make this 14 over 1. And then the u is x plus 3 to the 1/2 plus c. Oh, little mistakes. I gotta pay better attention. And we'll try one more of those, and I think hopefully you'll have it. Okay, number 5. Okay, we've got x cubed times the square root of x plus 2 dx. Okay, I'm going to rewrite this right now to the 1/2 power. So there's my inside. So u equals x plus 2. Du equals dx. Okay, when I look back, I've got an extra x cubed term in here that's not accounted for over here, so that tells me I have to convert everything to u's. So that means I need to solve this equation for x. So I'll be subtracting 2. So x equals u minus 2. Now I substitute. I will have u minus 2 cubed. X plus 2 is just u to the 1/2. And then dx is equal to du. Okay, I got a problem now because I still have an inside. I can't distribute this in here when there's a number out here that's not 1. It's a 3, so I can't distribute in. So the only option I have is to expand this so that I don't have an inside function. And I think I can expand it correctly today. I messed that up on the last section. I forgot my multipliers. So we know we're going to have 4 terms. 1, 2, 3, 4. And then I will still have this u to the 1/2 outside the parentheses that's got to get distributed after I expand. So the u is my first term, so I start with u cubed. Oh wait, see, I forgot to write 1, 3, 3, 1. I forgot the multiplier row on Pascal's, for goodness sake. Now I come in. U cubed. U squared. U to the first. U to the 0. Now it's a negative 2. Negative 2 cubed. Negative 2 squared. Negative 2 to the first. And that's it. So carry along the integral because we haven't integrated yet. I'll have u cubed. This will become minus 6 u squared. here I will have 4, 12 u, and then minus 8, all times u to the 1/2 du. Now distribute to the 4 baskets, and then we'll be ready to integrate. 1, 2, 3, 4. So distributing, I will get u to the, let's see, that would be 6 7/2 minus 6 u, that will be 5/2 plus 12 u to the 3/2 minus 8 u to the 1/2. So just added exponents. 3 plus a half, 7/2. 2 plus a half, 5/2. 1 plus a half, 3/2, and then 1/2. Now I'm ready to integrate each term with the power rule, so I drop the integral sign, and here I go. So I get u, add 1 to that, that will be 9/2 times 2/9 minus 6u, that will be 7/2 times 2/7 plus 12u to the 5/2 times 2/5 minus 8u to the 3/2 times 2/3 plus c. Now I will simplify the constants and back substitute for x. So final answer, 2/9 x plus 2 to the 9/2. Let's see, that'll be minus 12/7 x plus 2 to the 7/2 plus 24/5 x plus 2 to the 5/2 minus 16/3 x plus 2 to the 3/2 plus c. Whew. And let's just do a couple of quick trig ones and call it good. Let's see, example 6. Let's see if we have the integral of secant squared 3 pi x dx. Okay, before you start thinking there's an inside here, you always should first ask yourself, is there a trig function that has this as its derivative? Well, if you look, tangent's derivative is secant squared, so this is not a let a u equal the inside here. This is a direct, tangent's derivative goes right to secant squared. But with trig functions, the angle always is an inside function. So before we can integrate, we need the derivative of the inside function, which is the angle. So the du, don't be afraid of the pi. It's a number. This is like 3 times. Think of this as 9x here. The derivative of 9x would be 9. Well, the derivative of 3 pi x is just this constant 3 pi times dx. So before I can integrate this to tangent, I need a 3 pi attached to the dx. So I put the 3 pi here. But I can multiply by 1, so I put a 1 over 3 pi out here to actually hit the integral with a 1. So now, when I integrate, the 1 over 3 pi carries, and then tangent of 3 pi x is the antiderivative. Because when I take the tangent of this, I will get this. Okay, last one. Let's go integral of x sine x squared dx. Okay. I know that cosine's derivative is negative sign, so I know I'm close to having just a trig function here, but I have an angle to worry about. So you let u equal the angle. So the du equals 2x dx. Well, I got the X that I can slide over there. It's missing the 2. So I'll keep the sine x squared here. I'm going to bring the X down here so I can throw it away. The only thing I need to put here with it is the 2. So times by 2, so times by 1/2. And now it's ready to integrate. So, oh, I need the negative for the, because cosine's derivative is negative sine, so I need a negative cosine of the angle. Oh, got my 1/2 plus c. Okay, your assignment is going to be on that worksheet. We are going to pick up problems from the section 5.2, 19 through 45, odd, 22, 32, 34, and from the 8.4 section, which is the trig, 1 through 17 odd, picking up 6, 12, 14, and 16. And that will finish up section 5.4.